In this video, we're going to look at how temperature and pH affect the functioning of enzymes, and therefore the rate of enzyme-controlled reactions. Let's start with temperature. This graph here shows how the rate of an enzyme-controlled reaction changes with temperature. As you can see, for the first part of the curve, as the temperature increases, so does the rate of reaction. And this is because all of the particles will have more kinetic energy, and so they're more likely to collide and have enough energy to react. After about 37 degrees though, the rate starts to drop rapidly. This is because the high temperatures start to break some of the bonds holding the enzymes together, and so the active site starts to change shape. If it changes shape enough, then the enzyme won't be able to bind to the substrate and catalyze the reaction anymore. And at that point, we say that the enzyme has been denatured. So in this case, the enzyme would become denatured at around 45 degrees. And at that point, the damage is permanent. So even if you lower the temperature back down, the enzyme won't start working again. Another important term to know is the optimum temperature, which is this temperature here at which the rate of reaction is highest. So in this case, that would be 37 degrees. All enzymes have an optimal temperature, but different enzymes will have different optimal temperatures. The other factor that can affect enzymes is pH. pH is a measure of acidity, and as you can see on this graph here, if the pH gets too high or too low, then it will lower the rate of reaction. Just like with high temperatures, this is because some of the bonds holding the enzyme together start to break, and so the active site starts to change shape. At first, it just changes a bit, so the substrate can still fit, but less well than normal. This slows down the rate of reaction, but doesn't completely stop it. Soon though, the active site changes shape so much that the substrate can't fit at all, and at this point we'd say that the enzyme has been denatured. The pH at which the enzyme works best is called its optimal pH, and it depends on where the enzyme normally works. For example, most enzymes in our body work best at neutral pHs of around 7, like in this graph. But the ones that work in the stomach, for example, have an optimal pH of around 2, because they need to be able to function in the stomach's acidic environment.